One of the most captivating cosmic phenomena is the possible supernova of Betelgeuse. Situated in the well-known shoulder of the star grouping Orion, Betelgeuse is a crimson supergiant nearing the conclusion of its life cycle. Unexpectedly, in 2019, one of the most luminous stars in the heavens began to dim, noticeably discernible even to the unaided eye. For several months, its radiance diminished to such an extent that numerous watchers speculated whether the star was perishing. Aiming their telescopes at the massive star, researchers were amazed by proof of the significant dimming. Betelgeuse is thought to be on the verge of erupting into a supernova, signaling the conclusion of its stellar existence. The radiant scarlet star Betelgeuse is positioned on the upper right shoulder of Orion the Hunter. You might know it by its alternate title, Alpha Orionis. Even though it is the second most luminous star in that constellation, following the supergiant Rigel, it continues to intrigue scientists due to its fluctuating behavior and distinctive moniker. Alpha stars are generally the brightest within their constellations, and although Rigel surpasses it in brightness, Betelgeuse draws attention due to its enormous size and reddish hue. Betelgeuse, also referred to as Alpha Orionis, ranks among the most renowned stars in the night sky, being the 10th most brilliant and 7th most visible for much of North America, Europe, and Canada. Its designation is derived from Arabic and signifies the armpit of the giant, referencing its spot in the star grouping. Betelgeuse sheds approximately 1 solar mass every 10,000 years, releasing substances uniformly in all directions and generating a nebula surrounding it. This nebula spans 30 astronomical units, or 30 times the stretch between Earth and the Sun, and is 250 times more massive than the star itself. At its heart, Betelgeuse's hydrogen nuclei merge under immense gravitational pressure, creating helium and emitting radiation and warmth in the process. As the star depletes its hydrogen, it starts fusing helium and carbon as substitutes. When helium runs out, neon combines with carbon to yield iron. The merging of iron fails to produce energy, leading the star to cave in under its own gravity and ultimately burst into a supernova, one of the universe's most forceful explosions. Depending on age and developmental phase, stars emit illumination in varied wavelengths from the vivid blue of youthful stars to the red of elder ones. Based on the ancient stargazer Ptolemy, Betelgeuse exhibited a hue he intriguingly labeled as ruddy. Nevertheless, early Chinese astronomers remarked that Betelgeuse looked yellow, hinting that it may once have been a yellow supergiant. Massive stars rapidly burn through their hydrogen, leading to an early demise even if their existence spans only 10 million years. There's no question that Betelgeuse is in its concluding phase. While our Sun still possesses more than 5 billion years of life, Betelgeuse is approaching its final moments, meaning it could someday erupt in a supernova. However, the precise schedule of this occurrence is still unknown. Betelgeuse experiences 2 cycles of brightening and fading, one happening every 5 years and persisting for around 100 days. It's assumed that the swelling and shrinking of its outer layers during these rhythms prompt alterations in its diameter and typical surface temperature. Widespread interest in Betelgeuse grew during its unpredictable conduct in 2019 and 2020, when its light faded dramatically before recovering briefly. Certain scientists have theorized that this strange activity could indicate the star is nearing its final transformation. Comprehensive analysis of Betelgeuse dates back to the 1st century BC, yet the origin of its dimming remains an absolute enigma. Betelgeuse has been spotted moving through the interstellar environment at about 30 kilometers per second. After being thrown from its birthplace in the Orion OB1 group, which houses the stars of Orion's belt, the resulting bow shock extends beyond 4 light years. Measuring the proximity of red supergiant stars like Betelgeuse is an infamously difficult job in astrophysics, as various elements hinder accurate diameter estimates. Moreover, since it's a pulsating star, Betelgeuse's size varies over time. This characteristic, alongside the dimming of its outer edge, causes its observed glow to shift in color and diminish as we view it further from its core. Additionally, the shell of material expelled by the star plays a vital part in light emission and absorption, also affecting how we interpret its brilliance. Directly contrasting views of Betelgeuse is challenging since its visible size changes with the wavelength observed. These measurements can change by up to 35% based on the part of the light spectrum employed. In July 2009, the European Southern Observatory released visuals taken with a very large telescope, VLT, interferometer at its ground-based observatory, revealing a massive plume of gas stretching up to 30 astronomical units from the star's surface, one of many mass expulsions seen from Betelgeuse. This outflow matched the angular distance between the Sun and Neptune. At least 6 such events have been found around Betelgeuse. These occurrences might reveal clues to the question of mass ejection in the concluding periods of massive stars, which may be central to their destruction. The complicated processes within Betelgeuse's extended upper layers remain puzzling, as does the exact method by which red supergiants cast off their matter. Such stars are fundamental to the circulation of elements within galaxies, and due to progress in interferometry, astronomers are approaching solutions to these riddles. In 2019, scientists employing the Hubble Space Telescope and other observatories found that Betelgeuse had blown off a considerable portion of its outer shell, triggering a substantial surface mass ejection, SME. Though the Sun creates solar mass ejections, Betelgeuse's events were thousands of times more extreme, this time flinging out material 400 billion times the mass of a typical solar eruption. This accounts for why Betelgeuse suffered a steep drop in luminosity in October 2019. By mid-February 2020, it had lost nearly 3 times its brightness, shifting from magnitude 0.5 to 1.7. By February 17, 2020, Betelgeuse's brightness had stayed largely constant for more than a week. On the 5th, it looked like the dimming had stopped entirely. However, the recent reductions in visible light weren't connected to a probable core collapse, as no notable changes in infrared radiation were registered on February 24, 2020. When Betelgeuse ultimately detonates as a supernova, it will be among the most dramatic cosmic occurrences ever documented. Even at a distance of 640 light-years, the blast will be so radiant that it could outshine the full moon and even be seen during daylight for several weeks or even months. Experts estimate that the supernova will discharge more energy in mere seconds than our Sun will emit throughout its entire 10 billion-year lifespan. The illumination from the explosion will speed through space and eventually reach Earth as a brilliant pinpoint of light unlike anything we've witnessed before. But rest assured, we are entirely safe. Although a supernova that near may sound threatening, Betelgeuse remains distant enough that the detonation will not harm Earth's biosphere or living beings. What it will do is present an extraordinary scientific occasion. As of the last few years, Betelgeuse has returned to typical brightness levels, but its irregular dimming patterns are still under intense observation. Scientists are leveraging tools like the James Webb Space Telescope, the Hubble Space Telescope, and land-based interferometers such as the VLT and ALMA. They're tracking surface light fluctuations, patterns in convective activity, and continual mass outflows that seem to reflect the star's instability. One well-supported idea is that Betelgeuse's significant fading was brought on by a vast cloud of starborn dust created during one such eruption, momentarily veiling the star's light from our viewpoint. Grasping the mechanisms behind Betelgeuse could assist astronomers in decoding the life phases of gigantic stars, particularly those close to undergoing supernova. Such insights could help forecast similar phenomena in other galaxies, explain how chemical elements enrich the cosmos, and detail the formation and scattering of elements like iron and gold throughout space. Betelgeuse is effectively a ticking cosmic timepiece, and it's winding down slowly. It may explode tomorrow, next year, or in 100,000 years. But whenever it does, it will present a galactic spectacle and a wealth of scientific data unmatched in modern times.